storage and network ranging from 19th to 20th century. I have the pleasure to introduce you to Friedrich Kittler. Friedrich Kittler, born in Saxony, formerly East Germany, grown up in eastern and western parts of Germany, studied in Freiburg, and then moved on through the whole world, starting with his second Ph.D. called Discourse Networks. Maybe some of you are familiar with that book, because that book actually was like an earthquake in the German literature department. But nevertheless, he didn't stop there in the literature department. He also moved on from literature to media. Might be some of you people know the book Gramophone Film Typewriter. It's also on the list that someone should have given you. Maybe that comes out later. And from verbally dealt with everything in between: literature, culture, media, new media, old media, film, and computers. And Kittler not only knows, like a good scholar should do, literature, philosophy, and academic stuff from Greek antiquities until nowadays, but also has built himself hardware of computers. And that's why he is the person that does not only talk about media, new media, but also knows it from the inside. And he will hopefully give you within these 3 days an insight, like how to get from hardware to software, and what it means to live with media and in networks and use storage and get electrical power from currents, right? Yeah. And how you can critically describe these patterns and how they shape your surroundings and your environment. Friedrich Kittler has been teaching at Humboldt University since 1994, I think. By now, he's currently teaching there as professor for media philosophy it's called Stiftungsprofessor of Hubert Bode. He's financing him, and Hubert Bode has asked Friedrich Kittler also to close the gap between what the Germans call E and U culture. In other words, this saying that all our culture is based on media, no matter whether this is popular culture or highbrow culture, as we say. And basically this is something Friedrich Kittler will try to do here, teaching you all the basics of what shapes our world. I hope you enjoyed this course. If you have any further questions or want to find out more about his biography and resume, you can check out online. And I'm very happily handing over the word to Friedrich Kittler and hope you like this seminar.
This was Tanja Robin speaking. Thanks for your time. And you can address all practical questions. Somebody will know it. This is the third time I join into this graduate school. And today, let's start with some introductory remarks, and then we'll go into the real thing. We'll be together for 3 days, 3 whole days, and so I made up my mind roughly for 3 topics. The first topic to be dealt with today would be what I call electrics, the story about currents and flow and electric flows. After this short introduction, the second and probably most central part of it will be tomorrow and is called electronics in difference to electrics or electricity, and covers the 20th century. And the third day or third part will deal with actual trends, standards, and possibly and trends in the near future in hardware things we are unable to profitize more than, let's say, 15 to 20 years. And this is naturally the most difficult part of it at the end. My use of these key terms, electrics versus electronics, isn't necessarily identical to the use of other writers, but let's stick to this distinction for the time being. And what Tanya said in understanding, I'm not an overall expert, and I've some trouble with everyday language, English, also no trouble with electronic English. This is, as every device and every algorithm in electronics has got an English name. It's just like a second mother tongue. And in all these cases of darkness, obscurity, please ask questions, either whether immediately or at the end of some blog. This holds true also in cases of physics, mathematics, and history, especially military history, which I'm, as the title tells you, which I try to link as a driving reason for developments in media, technical, electrical, electronic media. Here comes a word, German word, which my lexica were unable to translate. Nevertheless, I wanted to say I'm a Zeitzeuge in a sense. I testify for all what's happened in the last 40 years. And I'm bound to say that my generation has really lived dramatic changes. When I was born, my half-brother was, for military reasons, dealing with electrical tubes, and he and I saw the arrival of the transistor as replacement of the tube, and finally desktop and laptop computers came into our life. Did we already tell you that a small list of recommended books will be distributed, or and English translations of books and papers by me? These could help as references, and another big or important reference are almost all the novels written by Thomas Pynchon. I'll make some cross references during these courses. As Tanya already said, my intention is truly basic. You're just not able to understand what happens around you here in this classroom and at your home without some understanding or comprehending electronics and some knowledge of computers. At morning you switch on your lamp, and at night you switch it off, and so on and so on. And I will this will be basic and elementary and necessary to understand what a switch is and what a transistor is and where the differences lie. And this understanding is quite another one than the usual covering done by the newspapers. Newspapers are only interested in, as far as I can see, newspapers are only interested in stocks and shares, Intel Corporation, Apple Corporation, and so on and so on. And what's going on inside, nobody cares for. And the second thought I had when preparing these courses, without intending to trouble your nation and your people, sometimes I get the impression that Americans are rather brilliant in inventing their having discovered all electronics in the world and all computers, and I don't know many things about Japan, let's say, but some Japanese inventions are mentioned, and the rest of the story, especially in the between the early 19th century and the end of the Second World War, is more or less a European history with surely big exceptions such as the wonderful Thomas Alva Edison. So to say, this course will be open software or open webware and open source, and quite in opposition to what Apple and Microsoft like to do, closed source and closed computers and no right to open the lid of your computer without risking your guarantees. I agree that opening your television set while under current would be risky, but in the case of computers, there's almost no risk in opening it. And the true reason for this closure, as Jacques Derrida probably would have said, the true reason is not published by newspapers, but by internal memos, and one of the internal memos written by Bill Gates, I happen to know, don't ask me how, why, he wrote verbatim, in the future we'll treat consumers just as computers, both are programmable. Yes, still some written remarks on my failing didactic capacities. Okay, the problem is to keep you on the run in a sense. I can't explain in one single sentence everything of this software and hardware question, so you, in case you follow with some patience, the elements of the story will come one after the other in a rather logical order. If didactic or not, I don't know. But there's one very helpful fact. The engineers are not so prosaic as they are said. I'd rather say that they are great poets because they are great makers. And and I mean with great poets that the engineers make up technical terms which are poetical, metaphorical, and self-explaining in many cases. To give just one famous example, tomorrow, when switching from electrics to electronic, we'll talk endlessly, not endlessly, about a device called flip-flop, and this is almost self-explaining, self-explaining its function. Flip-flop. This was the introduction. Any questions? When I spoke about this very classroom, I meant this video and your laptops, and the microphone isn't around, but could be, and the switch, and the lamps and the beamer. Now let's start with the real thing. It's a very strange fact or destiny, fact and destiny, that when we start with some science, when we start talking about some science, we are rather bound to speak Greek. Last year I think I had more time to spend with the Greeks and their invention of episteme, of science in general. And we speak Greek without knowing, for sure. When we say electricity, in which language do we use? Or electronics, so obviously Greek. Das muss ich vielleicht machen. Mit Eta und das nächste an. Und dann kommt Epsilon in der zweiten Silbe und dann kommt Omikron. Umgekehrt kommt, Entschuldigung. Jo, kann ich machen. Bin nicht ganz sicher, ob das wirklich ein Omikron ist. Electron as an adjective means brilliant, and as a noun it is amber. Amber found in the Baltic Sea and brought by famous ancient roads from the Baltic Sea down to southern Greece. And if you are rubbing this amber, you know it produces sometimes unexpected sparks, which in fact are electric sparks. So maybe, we don't know, but it could be that the Greeks meant, talking about amber, meant frictional electricity, Reibungselektricität. The root, the etymon of electron is unknown, but shouldn't bother us. two proper names are connected to electron. The first, electron, is an epitheton of the god Helios' son. He is the brilliant one par excellence. He shines, hopefully today. We have clouds since 4 weeks over northern Europe. And the second proper name is one of the most famous figures in Greek tragedy, Electra, written by Sophocles, for instance. Electra and Orestes, the daughter of Agamemnon and Clytemnestra, the brilliant young girl. Okay, so far, so much about electricity. And when we talk about the 19th century, that is today, we are dealing with not just with electricity, but mostly with electromagnetism, and so the question arises about the origin of the word magnet and magnetism, and the answer is also Greek. Magnetism has been called by the Greeks after a Greek city in Asia Minor, Magnesia, and we suppose with that certain assurance that near this city Magnesia for your ears, magnetic iron findings have been made. And one of the papers that we recommend for your attention is I've called Lightning and Thunder, and this is a small but sadly difficult paper on the difference between the Greeks and our actual experience and culture. And this will be a recurring theme, lightning and echoes. If you see these many thunders after one lightning, as many echoes of one almost timeless event, to get a better understanding of the mathematical structure of what electronics is. And at the end of this small excursion into classical Greek times, I posed myself the question once again, what could be the reasons that we always recur to the Greeks when we speak about science and technology? And the answer seems to me has been one convincing or elegant answer has been given by my Berlin forerunner, Georg Friedrich Wilhelm Hegel, who, giving a long famous lecture on the history of philosophy of world history was a title, and in the Greek part of it he explained other people than the Greeks, Assyrians or the Jews or the Egyptians, have had a heavy interest in monstrous or unnatural events, in wonders and monstra and so on and so on. And the unique fact about the ancient Greeks is that they wondered about the natural. What is amber? What is an echo? What is the light over the Mediterranean Sea? this doesn't mean obviously that the Greeks knew electricity or had discovered it or had made up a theory out of it in difference to the 19th century. But they started with atomism and chemical or physical elements, and the reason why only in at the beginning of the 19th century electricity came into a scientific focus. I've forgotten to pose myself still last week when preparing this course, and we should address it maybe probably during this very lecture of today.
Professor,
I have a question about that statement. You know, in terms of the focus on the natural, it's pretty brilliant assertion between the difference between the Egyptians or these other cultures and the Greeks. What part of does architecture play in that progression? Thinking of the mathematics of building with form like that, but also in differentiating that focus on the unnatural versus the natural, all the tribal cultures that are integrated in some harmonious way with their natural environments, they have mythologies about thunders or lightnings. But they didn't, like you say, in this thread that brings us to electronics.
Yeah.
So I'm just wondering if you have thoughts on that.
If I properly understand, these were two questions, the one about architecture and the other one about the naturalness and of the gods. I'm no historian of architecture. You should address our Portuguese architect lady. And to make a long story short, I'll just quote the last pagan Roman emperor, the wonderful Julianus. And he wrote 3 volumes in the Leyden Library, Harvard Press. He wrote himself, arithmetics, the Greek took over from the Babylonians. Sorry, arithmetics, the Greeks took over from the Phoenicians. Geometry from the Egyptians, and geometry from the Babylonians. Astronomy, yeah, sorry. Oh, yeah, richtig. But a new science which linked these 3 other sciences all together, the Greeks made up themselves, and this was music. And so these 4 sciences, this was a so-called cycle. The cycle as in the medieval quadrivium, or as in undergrad studies in a rough sense. And so music corresponds to arithmetic, and astronomy to geometry, and music links them all to a harmonious, this is word as you had it, to a whole, to a harmonious whole. And architecture and architectural tools as right angles, and so the Greeks obviously took over from older civilizations. And the question about the natural Greek gods, this would take us, I think, too far away from this course. The Greek gods and goddesses, not to forget the goddesses, were represented in a human form, yeah? In difference to other ancient cultures. And second, the differences between female physical attributes and male physical attributes wasn't exaggerated as in many very old cultures, but somehow lessened, so that an idea in between male and female became the classical representation in statues and drawings on Krügen, on jars. Thank you. So.
Maybe it could be interesting to make one short remark here about that the idea of canon, the idea of elements, the idea of atoms, so the idea of that basic structures are there that can be analyzed and divided into parts and brought together is something that was invented in Greece and is linked to the Greek alphabet. This is something Friedrich Kittler has done a lot of research on in the last years lately, and that is maybe why all science started in Greece somehow.
That is Barry B. Powell from the University of Wisconsin is my inspiration. I know him personally a bit, and this was in 1991. His great thesis that consonantic scripts exist in many parts of the world. Syllabic scripts have been invented independently in many parts of the world. In Japan, for instance, katakana and hiragana, or on the island of Crete, and not to speak about hieroglyphic writing scripts, and obviously Greek took over the geometrical forms of the Phoenician or North Syrian letters, but they changed it from an all consonantical script without any vowel to a script with 5 and later 7 vowels, and that's why we can read and write Greek on this very showboard without knowing Greek by heart or from rote or by mother tongue. In order to read the Old Testament, you have to without Orthodox churches, without written down vowels or diacritical signs for vowels, you can't understand the text. You can't read it, and the Greek vocalic alphabet is unique, obviously, in world history for analyzing the smallest elements of the voice, and to analyze it totally, so that with Greek letters or later on Latin letters, we can write English, German, and so on, and we can pronounce today, or still today we can pronounce Greek. We can't pronounce the hieroglyphs, Egyptian hieroglyphs, because we don't know the vocalic values. And as Randa said, so the Greeks had at their disposition a totally analyzed voice language. And this may, behind their backs, their inspiration to transfer the principle of phonetic units to other units. So, and though the atom was the unit, the smallest element of physics, and 4 elements were water, fire, air, and earth, were the smallest elements of chemistry, and so on and so on and so on. now we'll switch to the Middle Ages, which were not so untechnical as people believe. Lynn Wright, the great American historian, has done wonderful work. I'm unable to read Chinese symbols, letters, signs, so I can only repeat what I've read. Chinese troops, medieval China had a big enemy in the north, the Mongols, and they invaded China and they rode in the deserts and brought trouble over and over to the Chinese Empire. And Chinese armies were not enthusiastic about the idea to fight, to pass through these steppes and deserts and outside the limits of the war, the imperial wall and so on. And so they were thankful, grateful to their gods that they had magnetic iron with them, and so they knew in the far north, fighting against the enemy, were the south and Peking and the imperial and the sun of the heavens were to be found again when they marched home. So the compass was a giant. The use of the compass, magneticity, is first testified for the Chinese warfare. And by some unknown trajectories, the compass made its appearance in Europe in the early 13th century, as far as we can tell. And you probably know that compass needles in Europe were not so much used for territorial orientation, but for maritime orientation. The opening the almost infinite Atlantic Ocean would have been impossible without the use of the compass, and so America, in its European Columbian perspective, is a product of this technology combined with some other technologies, cartographic maps, and so these that are not important for our actual purpose. Friedrich Adolf, maybe the greatest German poet, once spoke of die schattenlosen Pfade der See, the path of the sea throwing no shadow and giving no orientation about the celestial directions. In European mythology or myth, the compass was rediscovered or brought into use by a citizen of one of the most beautiful medieval old cities of southern Italy, Flavio Gioia of Amalfi. Flavio is obvious, I hope, and But this was practical use and no theory at all. Only in, I've noted it, only in 1543, somebody in the important German town of Nuremberg, you know the name, made the remark that the magnetic compass needle had two opposite poles, and since some 50 years before this statement, the algebraic signs of plus and minus had been introduced for the first time into mathematics. The Greeks had numbers but no signs for mathematical operators. They simply said on and or plus also. And this arithmetical model of plus as a cross and minus as a horizontal line was projected, so to say, on the compass needle, one pole negative, one pole positive. And this will prove very important for the origins of the theory in the early theory of please keep it in your mind, plus and minus. Plus and minus have been introduced, and now the really first step towards theory of magnetism was done by a citizen of London town, William Gilbert, who published in the precise year 1600 his treatise De Magnete, on the magnet. And he discovered the reason for compass effects, and so iron can be magnetized or can be a magnet because it has been magnetized by another much bigger magnet, which is our planet itself, Mother Earth herself. So before iron gets magnetic, we live already ever in a big magnetic field. And I have to leave magnetism for a moment and go back to electricity. You remember the amber probably rubbed by little fingers, little Greek fingers, and this same principle of frictional electricity was transferred on a greater scale on the so-called bottle of Leyden, the university city in the Netherlands, with a let's be careful. This so-called bottle is said to have been invented in this university city. But the German tradition pretends, with reason I think, that one of the forefathers or ancestors, yeah, of the great German poet Heinrich von Kleist invented this bottle too, and it was a bottle. I'm not an expert at this point. It was a bottle of glass, I think, and inside the glass some you know this brilliant stuff into which chocolate is folded.
The what, sorry?
You open a
Aluminum?
no, not aluminium. It's shining and brilliant.
Cellophane? No.
No.
Deutsch?
Hm?
Wie heißt auf Deutsch?
Staniolpapier. Ja,
Tinfoil.
Tinfoil, ja. Tinfoil, thank you. In principle, this tinfoil bottle was tantamount to, as I said, to the amber stone, but in reality, in technical reality, the bottle worked much better, and you could electricize it much stronger, and after rubbing and rubbing, you got a little electrical shock. And after half an hour of electrifying, so to say, the capacity of this bottle went out in a moment, in a kind of electrical lightning. But and you see, you could construct this bottle in any place. You hadn't to go to the Baltic Sea, and painfully searching for amber stones. Electricity suddenly was at the disposal of science and technological research, because it had been technicized, let's say. And the capacity to shock produced the very name of this phenomenon, not the bottle, but the phenomenon produced by means of the bottle. Capacity, up to now, transforms itself into the capacitor for any device, every device able to store electricity for a lengthy time and to give it away, this capacity, this energy, in a rather shocking, sudden way, if it isn't controlled or hindered or blocked to give up this, to give out this energy. A capacitor, nowadays, the smallest capacitors are this dimensional, even smaller, and the biggest one I bought were this kind, but in electrical power stations you'll find capacitors as big as this room or so. The unit of capacity of capacitor energy, I'll come back, is called farad, after Michael Faraday, of whom you'll hear, and the mathematical symbol is a big C, and the technical technical symbol, I just will in these 3 days introduce you into 3 or 4 technical symbols in order to make most in order to be able to draw the most elementary electrical circuits. This small rectangle on the upper side symbolizes the plus pole, and the single horizontal line represents the negative pole of big capacitors. In the case of small capacitors, it's not necessary to distinguish between plus and minus. And the vertical lines, goes without saying, represent little copper threads or wires. Thank you. 2 wires to which the ends of this capacitor are electrically connected, as we say. In the last years, next step, in the last years of the 18th century, two Italians come into play. Galvani, whose name probably you know, Abbé Galvani, an Italian priest of a rather low degree, Abbé. Galvani had the strange, crazy, or even little, somehow cruel idea to connect the Leyden bottle with the legs of dead frogs. And after this Leyden bottle had been sufficiently electrified, without the connection to these legs and muscles, and then connected to this muscle, Europeans like to eat fresh frog's leg. Other people not so much. And the dead leg started to tremble or to it moved to tremble. It moved in a rather dramatic way.
Shake.
To shake, yeah. Good. And this was truly innovation in a literal sense of the word. The animal was dead, but the muscle flesh still alive. And this brought Abbé Galvani to the idea that the muscles themselves are somehow connected to electricity. And put it the other way around, that electricity itself was an animalic phenomenon, and in this conclusion he was proved wrong. But for 1 or 2 decades, this idea, this Galvani's idea of animal electricity was quite fashionable, not just one hypothesis among other hypotheses, but the leading and fashionable. Galvan. I should make when we speak of and we today speak about the galvanic coupling of electric currents, we mean a direct coupling without any intervention of capacitors or coils or so. It's just what galvanic coupling you do when you connect your laptop to an electric source on the wall. Now comes a very crazy story. I forget which Spaniard was responsible for this whole technical experiment. He was a physician, I'm sure, that so far I'm sure, and he heard in the 1790s that France had, for military reasons, introduced a telegraphic system without electricity, just optical. But this physician, inspired by Galvani, said to himself and his test persons, let's make up an electrical telegraphy here in Barcelona, from Barcelona to the harbor city of Mataró. And so he put up some 30 Leyden bottles representing the letters and ciphers of the Spanish Latin alphabet, and then electrical connections, simple wires, 30 kilometers, 20 miles from Barcelona to Mataró. And at the end of these wires, and at each end of the wire, stood one person, one man, holding the wire inside his or her hands, and now you could imagine how many shrieks corresponded to the telegraphic message, and A, B, and so on. Kittler, and I would be mad. But in 1804, I think, another Italian refuted Galvani's hypothesis. There is no... yeah. Stop. Yeah, and what regards the this fashionable character of the so-called animal electricity was proven by a wonder healer or charlatan or Franz Anton Mesmer, coming from Austria, and going to Paris. Was very popular in mundane, I think I should say mundane circles and circles of the French court and so, and animal electricity was used to form circles by men and women holding hands in the form of a big circle, and inspired by a Leyden bottle got into states which later on were called hysteric by the medicine theory after this dismantling or the unveiling of Mesmer and his magical pretensions. What you see, electricity enters even the realm of popular culture around the year 1800, and this popularity ends with Alessandro Volta. Everybody of you should be able to write the name, because voltage is immediately derived from his proper name, Alessandro Volta. And his invention was very simply the battery. He applied principles of French starting chemistry, Lavoisier and other great scientists of the French Revolution, to practical purposes. Lavoisier had undone the Greek theory of four elements and founded the modern concept of chemical elements, hydrogen and nitrogen or nitrogen and oxygen and so on. All these are his discoveries, and you see what the units, water for instance, take water. The Greek, for Greeks in general and Aristotle in special, water couldn't be divided into smaller parts. It was elementary, it was smallest element, but Lavoisier could easily show that water is tantamount to H2O. 2 parts of hydrogen and 1 part of oxygen, and these are the real scientific chemical elements since then. And inspired by Lavoisier, Volta produced elements of electricity, one positive, one negative, and whenever you change your battery in your laptop or your accumulator in the laptop, should be grateful to Alessandro Volta. Now, electricity, direct current flow was available without this hard work with Leyden bottles. That's why and as you know, in the early years of the 19th century, Italy was part of the Napoleonic Empire. The great emperor thanked Volta for his invention, or honored him for his invention. And this story runs immediately into the first technical war I've known. as I said, I should go back a little bit. To give you some historical background of early telegraphy, which has many things to do with Volta's battery and Lavoisier's hydroanalysis. How should I start? After the king had been beheaded, I think, decapitated. The French Revolution stood before the big question, who's the sovereign now? Answer, Jean-Jacques Rousseau, la volonté générale, the general will. But how to get information about this volonté générale? Impossible. In this Assemblée Générale, this General Assembly, some opponents said, okay, la volonté générale a été, is feasible in small Swiss cities and cantons such as Geneva, where Rousseau was born, but we are the whole of France is a big territory, and how can we inform ourselves about this general vote in a sufficiently small time? Up to now, information was transported by horses from Marseille to Paris or from Bordeaux to Paris. And so somebody, an engineer, proposed his optical telegraphy. Little houses like windmills, almost in form and feature, were put up some 15 or 10 miles from another in distance, and every one of these relay stations received an optical signal standing for letters and numbers, received it by it was a light signal, you see, and transmitted it to the next relay station, and the next relay station received it and transmitted it to the third, and so on and so on. And the city of Lille and its metropole of Paris are some 200 kilometers apart, but the message the French troops had won a victory in the surroundings of Lille, needed only 20 minutes to travel by means of optical telegraphy from Lille to Paris. And a great German scientist and physician andersrum. And so, yeah.
Would you like a glass of water?
Would be a good idea. Now, remember this discussion about democracy and a general will and sovereign as the whole people, and so it is the optical telegraphy covering the whole of France was quite expensive an act to build and to construct, but it was and in discussions the representatives declared we spent thousands and thousands of money for a good purpose, for the introduction of democracy, and everyone can take part in optical telegraphy. No, this was ideology, and in bloody fact, the French army was the sole and only benefactor of this optical telegraphy, and this was Napoleon's big advantage over his enemies in the Napoleonic Wars. In 1809, the newly founded Empire of Austria for the first time decided to attack instead of being attacked again and again by Napoleon. But the Austrian strategists didn't know enough about the technical infrastructure of Napoleon's power and military might of the optical telegraphy, and so the Austrians made the mistake to expect his military answer only in a space of 4 weeks, but by means of optical telegraphy, Napoleon's countermeasures took only one or 2 weeks instead of 4, and so he was victorious once again. The questions of real time and electricity and modern communication systems, you see, now we are at the heart of our problems. And now comes this great German physicists and scientists summering into play, who inspired by Immanuel Kant himself, a great philosopher, thought up an electric system of telegraphy combining this crazy Spaniard Lavoisier, Volta, and so on, in order to optimize optimize the optical telegraphy and to replace it by an electrical one. Mm. 35 cables, I think, for wires stood for the letters and ciphers of the German alphabet, and went not into human flesh as in Barcelona, but into little vessels where electricity dissolved water into hydrogen and oxygen, and this produced bubbles, and the bubbles could be seen, and this was the electrical telegraphical signal. And the newly crowned king of Bavaria presented Napoleon with this wonderful German invention of summering, and the emperor was very laconic in his answer and said, "Une idée germanique," a German idea, a crazy idea not to be implemented by the emperor, by the empire. Same story you may know. An American America and England and Britain were at the time were in incredibly worse, bad relations. And so an American came to Paris and to the emperor and proposed the steam machine and a steamboat for the French invasion of Britannia, of the British Empire. With a brilliant argument, the invasion fleet should wait until the wind was not blowing and the Royal Fleet without steamboats, military steamboats, could not sail, but the seaboats could easily transport French soldiers from Boulogne to Dover and London. This was, in Napoleon's eyes or ears, this was une idée americanique, an American idea. He didn't say this, but he declined the offer. Ten minutes and we'll make a break and cigarette pause and so on. And now things start to hit and to fit. Pieces come together. Danish philosopher, scientist, very famous nowadays. Originally, this O-N-E-R in Danish written this way. Ørsted, after many other discoveries, for instance, that of the element aluminium, and inspired by Immanuel Kant, the German idealism, made a crucial experiment. He traveled through Germany and met in university town of Jena the most brilliant romantic physicist, a German named Ritter, like Chevalier or Cavalier,